Welcome back, my dear children. Today, we're going to tackle a very interesting chapter, exponents and powers. And I promise you, by the end of this, you will feel like a math superhero.
So let's start with a mind-boggling question. Sounds impossible, na? Could a simple piece of paper, if you just keep folding it, actually reach the moon? Chalo, let's investigate this together.
You know, this looks like something straight out of a science fiction movie, but I'm telling you, the secret is all in the math. This is the magic we're going to uncover today. It's a magic called exponential growth. Okay, let's dive into this. Imagine a paper that's just 0.001 centimeters thick. Now, every time we fold it, its thickness doubles. So after just one fold, its thickness is 0.002 centimeters. Simple enough. After 10 folds, it's just over 1 centimeter thick. Still not very impressive, right? But after 26 folds, just look at that. It's almost 670 meters thick. Can you believe it? And this brilliantly illustrates the power we're talking about. That paper is now taller than the Burj Khalifa, the world's tallest building. It grows faster than you can imagine, kind of like a viral Instagram reel. So the crucial point is, this incredible growth is possible because of a mathematical superhero. Let's move on and see how this builds. It's time to meet our hero, the exponent. You see, instead of writing 2 times 2 times 2 times 2, we can just write 2 to the power of 4. The small number on top, that's the exponent, and the big number is the base. Easy. Now, every superhero has special powers, right? So let's learn the rules, or, as I like to call them, the superpowers of exponents. Okay, our first rule is for multiplication. It's just like the king's daughters getting more baskets of diamonds. When we multiply powers that have the same base, we simply add the exponents. So, n to the power of a times n to the power of b equals n to the power of a plus b. So, here are the 3 main rules you need to remember for your exams. For multiplication, you add the powers. For division, you subtract them. And for a power, you multiply. Don't worry, my dear children, we will practice these. Let's try a quick question. What is p to the power of 3 multiplied by p to the power of minus 10? Go on, remember the multiplication rule we just learned. Did you get it right? We just add the powers. So 3 plus minus 10 gives us minus 7. Well done. All right, now for a little plot twist. What happens when the power is 0? Does everything just disappear? Now, what's really interesting here is how we can prove it. We know any number divided by itself is 1. Using our division rule, we get 2 to the power of 4 minus 4, which is 2 to the power of 0. So, anything to the power of 0 is always 1. Remember that. And what about negative powers? Don't be scared of them. A negative power is just a way of saying 1 divided by. It's the opposite or reciprocal of the positive power. So n to the power of minus a is just 1 over n to the power of a. So you might be thinking, sir, where will I ever use this? Let me show you. Well, think about the password on your phone or a simple combination lock. How many possibilities are there? That's the power of 10 at work. Each digit has 10 choices. So for 5 digits, that's 10 to the power of 5 combinations. That's 1 lakh possible passwords. Now look at this huge number. This is the distance from the Sun to Saturn. It's so hard to even read, right? And this is exactly why exponents are so useful for scientists. They use something called scientific notation to write very big or very small numbers really, really easily. See how neat that looks? So, the crucial point to take away is this. Exponents describe multiplicative or exponential growth, which is much, much faster than simple additive or linear growth. That's the secret behind our paper folding magic. All the best for your exams, children. You are going to do wonderfully.